Suppose you want to amplify the marked region in the sequence by PCR. You have to start with primer designing. And what it means, there are a few simple steps. First step, you take the left bordering sequence somewhere here near the 5' end. Please remember, we always write the 5' end on paper or on computer on the left side like this. And for the target region, it is the 5' end is starting like here, right? GT, GT, C, GA, etc. So the 5' end is here. So I have to mark that sequence, about 25 nucleotides. I have used a few nucleotides only to save time. But when you write down, you got your forward primer done. Now, of course, this is the sequence written down. We have to get it synthesized by certain companies. All that is there, but our job is to write down. So we did that. What about the reverse primer? There are multiple steps here. A few steps only, very simple again. You mark the region at the 3' end like this, and you don't take that as it is. You have to do something extra. What is that? You have to get the complementary sequence, which is actually on the other strand of the double-stranded DNA. So for example, it is TG, TG, etc. So I have to start writing the sequence which is complementary like this, ACA, etc. And that is the sequence on the other strand. But please remember that this is the 5' end in the original sequence, and on the complementary sequence, the A represents the 3' end of that region I have marked. So I have to flip it so that the 5' end comes on the left. That's it. If I do that, basically I generated the reverse complement of the 3' end of the target region. So we have spent about 2 minutes to learn how primer designing works. Done. Now if you spend another 1 to 2 minutes, I will tell you what happens when you mix the primers with the template double-stranded DNA in the solution, because we do all this in few microliters of volume of buffer and other components. What happens there? You have to first remember that the DNA is double-stranded. I have only shown you the original sequence. Now I'm using a different color to mark the second sequence. Let's just put them as dots. Now what happens in the solution is the 5 forward primer would go and bind to the complementary region at this border target region like this. It will bind. The reverse primer, however, has to flip. It will bind in a reverse orientation to the original sequence at the 3' end, right? The second sequence and the original sequence. Now what happens if you add the enzyme? The polymerases will do their job. Polymerase will add polymerase will add nucleotides to the 3' end of the primer here, and also to the 3' end of the primer here. And this happens in one polymerase reaction. You have a chain reaction, and eventually you will have a lot of such molecules. A quick recap in a few seconds. You had double-stranded DNA shown in here is a line diagram. I have a target region like this, and I wanted to generate primers. So I took the forward primer like this, marked the region. I went to the other strand, but went to the complementary region, wrote down both the sequences, generated my sequences this way. And when I mix them, this is where the forward primer comes and binds, and reverse primer comes and binds here. And polymerase does its job. It will complete the polymerization. But of course, it doesn't stop here. You know, the reaction doesn't stop here or here. If you just want to know a little bit about that, I have another video for PCR. If you want to spend another 2 minutes, you will know some of the details I have mentioned there. But primer designing has a lot of other rules. You will see them in many textbooks. Just wanted to say that many of those rules don't matter. Only 2 rules are very important. If you want to know what are they and why am I saying only 2 are important, you can see the second video, which is about rules for primer designing. So my intention is to go on making such videos for 2 minutes to bring out the concept in complex concepts in simple way. That's my intention. I hope I did that here. Another one I would like to do, for example, is microarray, where primer designing and probe designing have similar concepts. So how that is important, I'll touch upon that while explaining microarrays. I hope I'll be able to do that also in 2 minutes. Anyway, I hope you like this video, and if you like, please share with others. Click on the like button here. Let me know if you have any feedback. I will continue doing my efforts. Thank you very much.